So this is the second of two videos on multiplying polynomials. In this section, we'll be examining how to multiply a monomial with a binomial. So you remember, monomial is a polynomial with one term. The binomial is a polynomial with two terms that cannot be combined. So in order to do this, you have to apply a really commonly spoke of property in math. It's called the distributive property. So let's think about what those words mean. So distributive, you're going to distribute or give out, right? So in this case, I'm going to spread out the term outside the brackets to both of the terms inside the bracket. Let me explain how that works. So in this case, I can see that anytime I have a number with brackets right beside that implies that I'm going to be multiplying the two parts together. So what this expression means, written like that, is that I'm going to say 2 times both parts in the brackets. So that means saying, well, 2 times the 3x and then 2 times the positive 5 separately. Remember that I can't add 3x and 5 together because they are not like terms. So what I get when I do that is I get, well, it's the same as multiplying a monomial with a monomial. It just takes an extra step. I'm going to be doing that twice. So 2 times 3x will give me 6x. 2 times positive 5 will give me positive 10. And I'm done at this point because always remember I cannot add a term with a variable in it to a constant terms. They are not like terms. Let's try a few examples. Okay, so right away I see this polynomial expression and I want to get rid of those brackets. So I'm going to simplify it by going ahead and distributing the 6 to both terms inside the bracket. So 6 times 4x will give me 24x. I'm going to go ahead and say, well, the 6 also needs to be multiplied by the second term in this binomial. But here's the kicker. I need to remember that the 2, I'm subtracting 2. So that really means I need to consider that as a negative 2. So 6 times negative 2 will give me a negative number, negative 12. And there's nothing more I can do with that question because I can't combine an x with a constant negative. Okay, so in this next example, I've added a bit of a twist because now I can see that I don't just have a constant outside the bracket, I actually have a variable term there. Okay, so but it gets managed in the same way. So let's take a look. So 3x times 1x, or simply x, will give me, well, 3 times 1 gives me 3. And then x times another x will give me an x squared. Moving on to my second term in the binomial, 3x times positive 7. Okay, well, 3 times positive 7 gives me positive 21. Since there's no variable to multiply the x with, it just gets tacked on to the end here. So some students will look at this next example and they might find that a little bit daunting, but it's really just a longer question, not a harder question. So let's tackle it. So instead of having 2 terms, I actually have 3. So this is in fact not a binomial, it's a trinomial, but the process for solving it will still be the same. I'm going to multiply each of my terms inside the bracket by the value located outside the bracket. So 8 times 2 will give me 16. And then there's no other variable to multiply the x squared with, so it just gets carried along. And I'm going to say 8 times positive 9x, and that's going to give me a positive 72x. And lastly, this is getting crowded up here, I'm going to go below. 8 times positive 3 will give me positive 24. Done. Cannot combine any of the terms. I can't combine an x squared with an x. Though, if I'm multiplying an x squared times an x, then I can get an x cubed, but I can't add an x squared to another x term because, again, they're not like terms. Let's look at one more example. All right, so now this is the most complicated type of question that you will see. In this case, I have a term with a variable in it outside brackets, and so I need to remember how to multiply a variable with a variable to complete this. But the process otherwise is pretty much the same as what we've been seeing. So let's work out our first term. 5x times 2x squared. Well, 5 times 2 is 10. X times x squared is x cubed. Next term. 5x times positive 4x. So 5 times positive 4 gives me a positive 20. X times x gives me an x squared. Now I'm ready to move on to my final term. 5x times negative 1. Well, 5 times negative 1 gives me a negative 5. And there's no other variable in that third term to multiply x with, so it just gets tacked on to the end. Easy peasy. So again, remember, I can't add a cubed with a squared term or with simply an x term. Those are not like terms because they don't have the same exponent, so I've simplified as much as possible. So in a similar way to what we saw with multiplying a monomial with another monomial, we can apply the same type of problem when we're multiplying a monomial times a binomial. You need to remember that the number of terms in my answer basically tells me how many terms have to be in one of the two polynomials that I'm multiplying. Let me show you what I mean through these two examples. Okay. I find that with this type of question, doing your check is really helpful to see if you've missed something. All right. So in this particular question, I know that I have to fill in the missing polynomial. And so I know that I needed to multiply 3x by some value right here in order to get 9x. Well, if I look at this, I know that, well, we have 3. 3 times 3x will give me 9x. I don't want to add an x in there in that first term because then I won't get 9x. I would get 9x squared. Now, to make sure that I've done this properly, I'm going to go ahead and make sure that that 3 out in front makes sense for all the terms in the second binomial, or in the binomial. Okay, so let's see. Well, is 3 times positive 5 in fact positive 15? Yes, it is. And so that tells me that putting a 3 as my missing polynomial was the right choice. Let's look at the second example. This is a little bit more complicated. Now, when I look at this example, I can see that I have 2 terms, right? So that means that in my answer, one of the 2 parts that are being multiplied has to have 2 terms in it as well. Otherwise, how am I going to get a minus sign between them? So let's work that out. So when I look at this, I'm going to say, well, the first part that I need is going to have to give me a 14x squared. Right? So what can I multiply 2x by to give me 14x squared? Let's start with the number part and break it down. So 2 times a number will give me 14. I know that that number is 7. But now if I stop there, 2x times 7 will simply give me 14x. But I'm looking for 14x squared. So that tells me that I need to add a factor of x in there. Then I can see that an x times an x will give me that x squared value that I'm looking for. Okay, so that's that taken care of. Now I'm on to my second term. So the second term in this question is my negative 18x. Okay? So I need to say to myself, well, what value will 2x be multiplied by in order to get negative 18x? Again, working with the numbers alone. I know that 2 times a negative 9 will give me negative 18. Now, let's work out the x part. I only see in my answer negative 18x. And it turns out that if I simply multiply the 2x times the negative 9, then the x has to tag along because it's there in my final answer. So, again, let's just do a quick check of this to make sure that all the parts that need to be there are there and that I have no extra parts there to make my answer incorrect. 2x times 7x does give me 15x squared. 2x times negative 9 does in fact give me negative 18x. So I've done that question properly. Hope this helps. If you're looking for extra questions on the internet to help you work through this, look up multiplying monomial with a polynomial, or a monomial with a binomial. You can also look up the distributive property. Those all are key terms that will help you find the appropriate extra practice on the internet, aside from your workbook questions.